today's lecture of functional analysis, I will be doing state and proof cauchys Schwartz inequality, one of the most important, and this appears most of the time in exams as well. Okay, so let me start with the proof. First, I have to state, right? Now, state and proof cauchys Schwartz inequality. The statement says that for any x comma y belonging to x, we have modulus of inner product x comma y is less than or equal to norm of x into norm of y. The proof starts like this. Note that the inequality is true if x is equal to 0 or y is equal to 0. So the inequality is true if either one of them is equal to 0. If x is equal to 0 or y is equal to 0. So what I have to do is, I have to assume that y is not equal to 0. Then for any alpha belonging to k we have, now for any alpha belonging to k we have what? Let me do it on the next page. We'll be doing it over here, okay? Let me. Inner product of x plus alpha y comma x plus alpha y is greater than or equal to 0. Now how we are going to do this as? Now this implies inner product of x comma x plus inner product of x comma alpha y plus inner product of alpha y comma x plus inner product of alpha y comma alpha y is greater than or equal to 0. So here what I have done is, now see, okay, x, inner product of x into x plus x comma x it is, then plus inner product of x comma alpha y, then plus inner product of alpha y comma x here, and then inner product of alpha y comma alpha y here, which is greater than or equal to 0. Okay, so next step is what? Now what is this? Norm of x the whole square. Here it will be norm. Okay, this, let me do this step first. Now this implies what? Norm of x the whole square plus alpha bar x comma y plus alpha y comma x. Okay, I'll do this directly, okay, here. X comma y, so it will be modulus or bar, sorry, bar it is, okay, x comma y bar, then plus alpha into alpha bar y, okay, so this is norm of y the whole square, right? Norm of y the whole square, which is greater than or equal to 0. Let me turn the page and write. Now this is equal to norm of x the whole square, then what is there? Plus now this thing I'm going to write it as twice real alpha bar inner product of x comma y, okay, this. So it will be twice real alpha bar x comma y plus modulus of alpha the whole square to norm of y the whole square is greater than or equal to 0. Now what I'll have to, now take your alpha bar has minus inner product of y comma x upon norm of y the whole square. So that is, what is my alpha is equal to minus inner product of x comma y upon modulus of y the whole square. Sorry, norm of y the whole square. Okay. Now let me turn the page. So what I have to do over here now, let me explain you. Now this value I have to substitute in this. Okay. Wherever there is alpha, you'll have to plug the values in that. Okay. So let me do it. Norm of x the whole square plus twice real, then put minus modulus of inner product of x comma y the whole square upon norm of y the whole square. Okay, plus, let me write it here, I'm not getting a place there. So x comma y the whole square, let me do it properly, okay, so that there should not be any, plus what I said, modulus of inner product, right, of x comma y the whole square into modulus of y the whole square, sorry, norm of y the whole square upon norm of y raised to power of 4 is greater than or equal to 0. So why I have done this raised to power of 4? Because it is here it is. So it is modulus of alpha the whole square. So square is for both, right? When I substitute this value, so alpha is for both. So it will be, it was 2 right here, but if it is square, then it will become raised to power of 4 over here. Okay. Now what I have to do is I have to cancel this term with this term. So what will remain? So if I cancel this term, what is going to remain is norm of x the whole square minus twice modulus of x comma y the whole square upon norm of y the whole square plus modulus of inner product of x comma y the whole square upon modulus of y, norm of y the whole square. Okay, it is. So what will remain is, now this is greater than or equal to 0. Write down there, greater than or equal to 0. Then norm of x the whole square minus 2y's modulus, sorry, 2y's won't be there because so what will remain? X comma y upon this, right? See, if this is 2y's this thing and this, so minus this plus this is what, only one term will remain, right? That is modulus of inner product of x comma y upon norm of y the whole square. Now I will take it this side. Before that, put this greater than or equal to 0. Then what I'll do is norm of x the whole square into norm of y the whole square is greater than or minus modulus of inner product of x comma y is greater than or equal to 0. Now what I'll do, therefore modulus of inner product of x comma y is less than or equal to norm of x the whole square into norm of y the whole square, which is nothing but modulus of inner product of x comma y is less than or equal to, this square is deno for this, is nothing but norm of x into norm of y. So we are done with today's lecture. I hope you all have understood this Cauchy Schwartz inequality. This is very important for the exam purpose. I will be doing more proofs, more theorems on basis of this. Okay. Thanks for watching.